Hello everyone. Welcome back to my channel. Today we're going to tackle a hard problem on LeetCode. It's called maximum building height, and we're going to break it down step by step. So make sure you stick around until the end. This problem is quite challenging, but with the right approach, it's definitely solvable. So let's get started. The problem statement is quite straightforward. We have a certain number of buildings, and we have some restrictions on the heights of these buildings. Our goal is to find the maximum possible height of the tallest building. We're given the number of buildings, and we're given a list of restrictions, where each restriction is a pair of building index and the maximum height of that building. So, the core insight here is to think about how we can update the restrictions based on the adjacent buildings. Imagine you're building a skyscraper, and you have a neighbor who has a height restriction. You can't just build your skyscraper to be super tall if your neighbor has a restriction. You need to take that into account when planning your building. Similarly, in this problem, we need to update the restrictions based on the heights of the adjacent buildings. And that's the key to solving this problem. Now, let's walk through the solution. We start by adding a restriction for the first building, and then we sort the restrictions based on the building index. This is because we want to process the buildings in order, from left to right. Then, we update the restrictions for each building, to ensure that the height difference between adjacent buildings does not exceed 1. We do this by iterating through the restrictions twice, once from left to right, and once from right to left. This way, we can update the restrictions based on the heights of the adjacent buildings. Now, let's dive into the code. We start by adding a restriction for the first building, and sorting the restrictions based on the building index. This is done with the line restrictions, push_back, 1, 0, and then we sort the restrictions with the line sort, restrictions, begin, restrictions.end. Then, we update the restrictions for each building, with a for loop that iterates through the restrictions, and updates the height of each building based on the height of the next building. We do this with the lines for int I equals 0, I less than restrictions, size 1, I plus plus, restrictions, I 1 equals min, restrictions, I 1, restrictions, I plus 1, 1, plus restrictions, I plus 1, 0, restrictions, I 0, closing curly bracket. We also do this in the other direction, from right to left, with another for loop that iterates through the restrictions in reverse order. Finally, we calculate the maximum possible height for each building, with a for loop that iterates through the restrictions, and returns the maximum possible height. The time complexity of this solution is O(m) log m, where m is the number of restrictions. This is because we first sort the restrictions, which takes O(m) log m time, and then we iterate through the restrictions twice, which takes O(m) time. The space complexity is O(m), as we store the updated restrictions in the input vector, and use a few extra variables to store the maximum possible height. And that's it. That's the solution to the maximum building height problem. I hope you guys understood the intuition behind the problem, and the code explanation. If you have any questions, or if you have a different approach to this problem, please let me know in the comments below. Don't forget to like the video, subscribe, and comment your approach below.